Hi folks, this is Nat. This is going to be your video lesson on expressing and understanding probabilities as fractions, decimals, and percents. You can express a probability in all three of those ways, although some are more common than others in different situations. And we also, because you can express probabilities in a lot of different ways, we want to be able to compare probabilities and say which is more likely and which is less likely. If you are unfamiliar with probabilities, a probability is a way of mathematically telling how likely something is to happen. So in any situation where we're not actually sure what might happen or what could happen or what will happen, we like to sometimes use probabilities to give us a sense of what is probably going to happen or what will never happen. So these words here are some of the ways we might describe probabilities verbally, and you're probably used to saying these sorts of things. I never wake up younger than I was when I went to sleep. I sometimes might be given homework by my teacher. I always blink during the day. So we all have sort of a general understanding of probability in the sense that we use it all the time to describe things. And we're used to word form. And what we're going to be really kind of delving into is how do we describe probabilities with numbers, which are going to be hopefully a little more accurate and tell us more than some of these word probabilities. Probability exists on a scale from 0 to 1 as a fraction or a decimal, or from 0% to 100% as a percentage. So if something is never going to happen, it has a probability of 0. If something is always going to happen, it has a probability of 1 or maybe 100. So you could say there is a 100% chance that when I roll a dice, I'm going to get a number. You know, assuming it's a dice with numbers on it. Most things, though, don't really fall in that never or always category. There's a lot, it's actually really hard to think of things that are absolutely never going to happen or always going to happen. Most things could be, lots of things could be very likely to happen or very unlikely to happen. But just because of the way life works, it's actually, unusual to find something that's always going to happen, that's always true. I could say, there's almost 100% probability I'm going to go to sleep at the end of the day, but you could probably think of reasons why that might actually not happen. Maybe I get hit by a bus. So most things fall into this sort of sometimes category, and that could range from things that almost always happen to things that almost never happen, but they're not 0 or 1, 0 or 100%. So right in the middle of sometimes is the idea of things that are going to have equally likely to happen or not happen. So those things happen half the time as a fraction, or as a decimal, you might say 5/10 of the time, or as a percentage, you might say they are 50% likely to happen. And things with these mathematical probabilities are equally likely to happen as not. Things that are more likely to not happen might have probabilities like 1/4. If something happens 1/4 of the time, it's less likely to happen than it is to happen, but it could happen. The decimal equivalent of that would be 25 hundredths, and then 25% would be your percentage for that sort of a situation. On the other end of things that are increasingly more likely to happen, we might see things like 3/4 of the time something happens, or 75 hundredths, or 75%. And there are all sorts of other in-between numbers that these things could be. So hopefully what you can see is that there's lots of ways to express how likely something is to happen in math, and they all seem to fall under fractions, decimals, and percents. So because of that, it's really important to review how fractions, decimals, and percents relate to one another, because you might see a probability as a percent and need to wonder, well, how does that relate to this other probability that's a fraction? So we need to be able to convert fractions, decimals, and percentages so that, for one reason, we can compare probabilities. Because it's very difficult in a lot of situations to compare a fraction to, say, a percent. So let's say, hypothetically, I have the fractional probability of 7/8. Something is going to happen 7 out of every 8 times. If I want to take that fraction and turn it into a decimal, an easy thing that I can do, if you remember, is treat it as a division problem. I can say, well, that's 7 divided by 8, which is going to be 0 and 875 thousandths. So now I have my fraction as a decimal. I could take that and just move the decimal a couple times as a percent, or I could say, well, what is it as a percentage? And I could set it up as a proportion. 7/8 is what out of 100? And what I'd discover is that it was 87 and 5/10%. Alternatively, if I had a probability as a percentage, let's say it was 68% of the time something was going to happen, I could really easily convert that into a decimal simply by moving my decimal point 2 places to the left, or dividing by 100 would be another way to think of it. So 68% becomes 68 hundredths. Which makes sense, 68 out of 100, 68%. As a fraction, I know that all percentages are out of 100, so 68 out of 100 could give me my fractional form, and I might then want to reduce that down, dividing by common factors, which we'll cover later. So that's the same as 34/50ths, or I might say that it's the same as 17/25ths. I'm kind of moving through this fast just because I'm hoping this is review from before, but if you don't remember this stuff, remember we have lots of different conversions we can make. Each one has its own little rule. Lastly, we don't often actually see decimals as probabilities or probabilities as decimals, but if we did, we should be able to deal with it. Let's say, for example, we had 22 hundredths and we wanted to make that a fraction. Well, it's 22 hundredths, that's 22 out of 100. And again, I'd probably want to reduce any fractions. I'd call that 11/50ths. And then on the other side, we've got this idea, well, if it's 22 hundredths, I can just multiply that by 100, or move my decimal 2 places to the right using my butt cheek method, and I can get to 22% pretty easily. So it should be hopefully pretty simple kind of review work for you all to be converting probabilities in these different forms, because we've already worked with these different forms earlier in the year. Another concept that's really worth kind of covering, for some people it feels really intuitive, for some people they have some trouble with this, it's the idea of opposite probabilities. Let me give you an example. Let's say the probability that you do homework tonight is 95%. Again, I could express that differently as, let's say, a decimal, 95 hundredths, or as a fraction, 95 over 100, which reduces down to 19/20ths. An opposite probability is the probability of the other thing happening, or the opposite thing happening. So if I'm talking about the probability of doing homework, the opposite probability is going to be the probability of not doing homework. And if I asked you what's the probability of not doing homework, you should be able to come up with it relatively quickly. Since all probabilities as percentages, if we think about this 95%, are out of 100, the opposite probability is going to be what's ever left over to make 100. So if it's a 95% chance of doing homework, that means that there's a 5% chance of not doing homework. Similarly, decimals are out of 1, and so are fractions. And so In order to get to 1, whatever's left is going to be that opposite probability. So if there's a 95/100ths chance of doing homework, there's a 5/100ths chance, the remaining 5/100ths to get to 1, of not doing homework. Fractions are also pretty simple. If we think of a fraction of being out of 1, whatever's in the denominator, if it was in the numerator, would be 1. So 20/20ths would be our whole in this case. And so if I have 19/20ths for doing homework, what's left is 1/20th for not doing homework. And these are our opposite probabilities, and you should be able to come up with these pretty easily. Finally, for today, we want to be able to compare probabilities, which is basically just being able to say which is more likely to happen, which is less likely to happen. Or, if you just want to think about the numbers, which is the smaller number, which is the bigger number. The big thing we need to do when comparing probabilities is make sure that they're in a common form. So if we have one fraction and one decimal, we want to convert them to a common form. It's really hard to compare probabilities that are in different forms. For example, and these are actually true, you have a 4% chance of dying of a stroke. Alternatively, you have a 1 in 77 chance of being hit by a bus or a train. If I wanted to know which of these was more likely, I could probably noodle it out, but if I want to prove it, first of all, I'm going to have to convert them to a common form. This is where maybe your decimal is really useful. So for example, I can convert 4% to a decimal by moving the decimal place 2 places to the left. 4/100ths is the same as 4%. And I can also convert my fraction to a decimal very easily by treating it as a division problem, 1 divided by 77, which I discover is about 1/100th. And that makes it really easy to prove that you are about 4 times more likely to die of a stroke than being hit by a bus or a train. So when we compare probabilities, it's really useful to be able to do these conversions so that we can convert them to a common form if they're not already in one. So here are your practice problems. Make sure that you read them carefully and answer what you're being asked. Good luck.